It's really cool to see so many people out here interested in living shorelines. So thank you for coming out. Um, yeah, like Kathy and Marilyn said, I'm Eddie DeVita. I'm a civil engineer with Environmental Science Associates and was part of the design team for the Heron's Head Shoreline Resilience Project, which during some of the walking, someone asked, like, what is the project we're talking about today? And the Resilience Project is just one of like several projects that are kind of layered and interacting at Heron's Head Park. And then with the Rawls Project interacting and layered around the region. And so what my presentation on here is pretty specific to the shoreline, the gravel beach, the other habitat elements, and then Nina and Momo will be jumping in to talk about Ledge's work with the vegetation. And it's so good to be able to walk the site with you all. I think I may have given away the punchline on a lot of the pieces I'll be talking about, but sometimes it's useful to hear things a couple times. So we're gonna do it. I didn't have the mic, it was loud. Yeah, that's right. And I will go fairly quick. I have too many slides for 20 minutes, so I will jump through. And I know not everyone can see things, but we'll just keep it moving. And I think we want to save time for questions at the end. So yeah, here we go. Next slide. Huge project team. No project like this can happen without a team behind it. I'm not going to name everyone, but the funders I think are super important. The San Francisco Bay Restoration Authority. I know you can't read any of these. Coastal Conservancy, CDFW, Ocean Protection Council. Project couldn't have happened without them. Port of San Francisco, the owners and champions made this happen. And then Kathy, Chayla, a bunch of folks, Marilyn, like this just huge team effort. My role was on the civil engineering design. And so I'm kind of bringing that perspective. There's also ecology and plants and construction, so many disciplines. I'll try to answer your questions, but again, I'm an engineer, so I'll do my best for those other things. Next slide. I talked a little bit about the history of the port, and so this is where you are. You all made it here today, so I'm not going to spend a lot of time on it. Welcome to Heron's Head Park. Next slide. So this is a cool map I found from the Oakland Museum. 1869 shows the historic shoreline of San Francisco. And everyone here probably knows how just altered the bay edge has been. And Heron's Head is no exception. If you go to the next one, we're going to start to overlay a modern map. And basically this peninsula that we're on, this was all built. This is not a natural landscape. This was constructed over the course of the last 150 years. The big effort, and if you go to the next slide,
I had to go back.
and oh, there we go, one more, and then one more. The big effort that ultimately resulted in the creation of Pier 98, which is the original name for this landform we're now sitting and standing on, happened in around 1960, 1970. So the port manages the entire waterfront north of here out to, I think it's to Aquatic Park. And this is the southern boundary. Halfway through India Basin is the edge of port property. Pier 98 would have been the last port or pier constructed by the port. They built basically half of it. And this was a time when there was a lot of transitions in the type of technology that was used for hauling freight. And there was a migration of the ships coming, which originally would have come to San Francisco side of the bay. They were all switching to container ships, going to Oakland where they have the big cranes and can offload things. And so the port did some economic analysis, decided that they actually didn't need a Pier 98. They stopped building it. It was halfway done. You can see, okay, you can't see. The photos are pretty small on the screen, but they basically built it by bulldozing rock, rubble, dirt out into the bay. They never finished the construction. And one of the last steps in building a shipping terminal is building the seawall around the edge. And that's how you can kind of dredge it out and create a deep channel that the boats can come in on. That seawall also is what keeps the mud and the dirt in the middle from eroding. Because they never built that, this peninsula that they constructed, not a natural landform, waves are hitting it, it's built with soft dirt, slightly compacted, not fully built, starts washing away, starts melting into the bay. As that happens, parts of it get into elevations that can support tidal habitat. And so you had this like melting landscape. It wasn't melting super quickly. You get plants showing up, and then BCDC gets involved. BCDC is the agency that regulates fill in the bay. And for a long time, they were very opposed to filling the bay because usually that meant building a levee, going and constructing something on top of what used to be really good marsh habitat or wetland habitats. So much of that habitat had been lost. In particular, a lot of that habitat had been lost along the San Francisco Bay edge. And so it was very cool when marsh habitat started showing up at Heron's Head Park accidentally. And a bunch of folks got together, Audubon, Arthur here can tell the story in much more detail. But ultimately, it resulted in a project in the mid-90s to create and kind of formalize this as a habitat-focused landscape. They did a bunch of earthwork to lower some of the remaining high ground, created, I think it was something like 10 acres, might have been 12, of tidal marsh ponds. There was a channel network and the trail. A few years later, they came and built this eco center, early 2000s. They never, though, addressed the edge erosion issue. And as they created the habitat, then they got the plants. There's a lot of work. Ledge got involved. Nina can tell you about the efforts to get good native plant species composition out here. But the edge was continuing to erode. In the mid 2010s, one of the largest salt ponds, if you go to the next slide, not salt ponds, one of the largest tidal ponds in the middle of the site breached and converted to mudflat. And those ponds are created as a feature to support certain bird habitat that can forage in the shallow water. And so when that breached and let waves kind of get into the middle of the marsh, started eroding away from the edge, in some places up to 100 feet of erosion had occurred. And so that motivated the port to do this shoreline resilience project. Go to the next slide, please. Which kicked off with an analysis to understand the wave conditions here. So why is the shoreline eroding the way it was? And we did a coastal engineering study. It included putting a wave buoy out in India Basin. We also used a tool called SWAN, which is a two-dimensional wave model that can estimate the direction and height period of waves under certain wind conditions. And this graphic here, which you also probably can't actually see, but it has little arrows that are showing the direction of waves approaching the site during a large storm. And what's important to note here is two things. The predominant direction of large waves approaching the site are coming from the southeast. They kind of wrap right around Hunter's Point, approach the site, and so they're approaching the site at a diagonal, which means that the forces of the waves are directed westward, which will get important when we start talking about the beach design. The other thing to know is that this site, the peninsula was pushed out into the bay, was built on mudflats and then getting into subtidal areas. So there's this gradient of depths offshore. You go from pretty deep water at the offshore tip of the peninsula to very shallow mudflats where we were over by the overlook this morning. And so it's about a 5-foot drop in elevation as you go over that, and maybe 3 feet. But it's pretty notable, and that results in a big difference in the wave climate as you go from the east side to the west side of the site. You get very big waves at the tip, much smaller as you're over here on the west side. Next slide. And so we started off the project. I'm not going to read all of these, but the goal of the project was to come up with a nature-based or a kind of naturally appropriate, ecologically appropriate design to improve the resilience of the shoreline. One other thing that I'll mention is that as we were doing this design, the port was also very interested in a project that would be resilient through 2050, which is, there were a lot of conversations around that. A lot of engineering projects have a design life. Usually infrastructure, it's at least 50 years, sometimes 100 years. Port engineers are used to that sort of time scale as they're building, if you're building a bridge or if you're building a revetment. That kind of time scale is not possible to achieve with a beach. A beach is a beach because the sediment moves. It's not riprap. If the sediment was static, it would not be a beach. And so that washing around of the material is what lets the crustaceans and the plants and everything do what it needs to do on that landscape. It also means that as it's going to inevitably wash downdrift. And that's just how these landscapes work. And so we were aiming with this design to have something that would persist through 2050. There's also a lot of uncertainties with sea level rise beyond that. And so that kind of time frame made sense as we went into the planning for this. Let's go to the next slide. This shows what is often referred to as like the green-gray spectrum of shoreline designs, and that was something we thought a lot about as we were developing concepts. We did, I think, 2 or 3 iterations of alternative analyses for this project. The first one was kind of a high-level screening, just like what type of landscape do we want here? We knew we wanted it to be natural. We knew we wanted it to be ecologically appropriate, compatible with the wetland habitats and with the mudflats that were nearby. So that gets us thinking about things like beaches. We also thought about just vegetation. What happens if you just do more plants? There's some landscapes where that would work. Very sheltered if the waves are small enough. Wouldn't work at this site. The waves are just too big, it would wash away. We also looked at things like cobble. What if you used, so there's precedents around the bay for like where headlands meet the edge and you do get natural accretions of cobble, small boulders. That is a natural landscape in some places, but it doesn't support the type of plants and wildlife that you would want to see here. And kind of understanding the work that Ledge is doing, the opportunities with the Sueda reintroduction, gravel looked like a very good approach because the beaches are kind of sort of compatible with the waves, in particular on the more sheltered side of the site. We knew we were kind of on the fringe on the east side, 4-foot waves will move a lot of gravel. We also found this source of gravel right nearby. And so Pier 92 has a facility where they offload sand that's dredged from the bay, stockpile it, sort it. Most of the sand is used for construction, goes into aggregate for concrete. They screen out the gravel, and sometimes they'll crush it to make more sand that goes into the concrete, but that crushing is expensive. And so that supplier, at that time, it was Hanson Aggregates, I think it's now Martin Marietta, was willing to stockpile and donate 10, 15,000 cubic yards of gravel and give it to the port. It's hard to say no to that. And so that is the material we used. And I mean, we did a lot of, we looked at other sources. We looked at the gravel that they had available was 5 to 10 millimeter diameter. You probably saw it. It's not huge. It's kind of like pea-sized. Given the waves, especially on the east side, you might have wanted something larger. So there was some compromise that happened. It might have been $1 million to purchase that material though. And so the balancing act with developing the design kind of navigated that, and we ended up with this approach, use that material, include some structures to slow down the movement of the material, and then focus on planting and monitoring and see how it evolves. Next slide. Here is a map of the project design. And so it's a 1,600-foot long beach. It was about 13,000 cubic yards of gravel. Roughly 2/3 of that is what we call the main beach, which was along the eroded pond and some of the eroded marsh edges and some of the ponds that hadn't breached yet, but were close to breaching. And then the remaining third, about 4,000 cubic yards, was on the east side of the site, the more wave exposed area. That is what we were calling the feeder beach. And there weren't any features there that were like imminently vulnerable. No ponds about to breach, no really like exposed, sensitive plants. But putting material there creates a source that's going to wash down towards the pond areas and make sure that we have gravel there for some extent into the future. Next slide. We also included a handful of different habitat elements in the project to kind of improve the ecological functions of the beach. Those include the oyster reefs that some of you saw. There's 60 of these reef balls that were put out on the mudflat just offshore of the toe of the beach. For this specific project, there was a fair amount of discussion over whether these should be used as a wave break, because in some contexts, reefs can be used to dissipate wave energy. At this site, we didn't design them to reduce wave energy, but we know they'll provide additional benefits. Part of the reason for that is it's very difficult to quantify how much wave dissipation you'll get from a reef structure. And it introduces all sorts of regulatory complexities, but we know they're good habitat and know they'll be a little bit beneficial for waves. So that's the approach we took for this project. We also included driftwood, or not driftwood, artificial wood habitat elements to mimic driftwood. That's wood that's embedded in the crest of the beach to kind of create a little bit of complexity. It can create areas that are sheltered for plants to colonize, perches for birds, and just adds a little bit of natural-ish variability to the landscape after construction. We've also seen some natural driftwood accumulation. Next slide. So here's some photos of construction. If anyone has questions about this, there's a whole lot of lessons just from how they built this. This was built by Dixon Marine Services. Super helpful to have a contractor like them that was creative and very thoughtful about how to operate in the marine environment. There were some very challenging constraints here related to permitting and how to protect the existing sensitive marsh habitats, working around low tides, working next to water without letting the equipment actually create turbidity or other conditions that would be problematic for fish. One thing that I thought was pretty creative was in bottom middle picture, they created this gabion, you might call it a causeway. It was a temporary access road. They basically used the gravel that ultimately ended up in the beach, but they put a temporary road built from the gravel contained in these fabric and mesh baskets that worked quite well. That's how they were able to get the haul trucks out to actually place the beach material. Next slide. I've got some lessons from construction. I kind of just summarized them briefly. One other thing I'll say is that this project was built in 2022. It was still very COVID-y at that point in time. And so there was some challenges with just the whole construction process, stockpiling, how do you control the material that's brought to the site? One thing that was unfortunate with this project was we didn't have great quality control on the rock that was delivered to the project. And a fair amount of the large rock that was used to build those retention structures was slightly undersized. And what we're seeing now is that the easternmost rock structure is starting to degrade. And so that was the structure at the most wave exposed portion of the site. The rocks were about half the size of what we had wanted. And now they're rolling around, and that's unfortunate. We're keeping an eye on that. We might have to do something, but yeah. Next slide. Cool. And now I'm going to hand it off to Nina, who's going to talk about Ledge's great work. How are we on time? I probably went.
Great. Yeah. Hi, everyone. Thank you, Eddie, for the introduction on the project. Again, my name is Nina Omomo. I'm the Community Stewardship Manager at Literacy for Environmental Justice. Ledge was contracted by the Port of San Francisco in 2021 to execute tidal wetland restoration over a 5-year period as part of the Living Shoreline project. The purpose of the project is to use nature-based solutions such as native plant establishment to stabilize the quickly eroding shoreline at the park under the threats of sea level rise and storm surges. Our goal as a nonprofit is to provide workforce development for Hunters Point Bayview residents, specifically young adults, through our work. Our work being habitat restoration, running the native plant nursery, urban greening, and outdoor education for the youth. Next slide, please. Quickly go through some of Ledge and our partnerships: Port of San Francisco, ESA, SF State Estuary and Ocean Science Center, Candlestick Point Restoration Area, Cal IPSI, California Recreations and Parks. Next slide. All right, and to get into our work and the restoration that we've done here, we have to go back to our roots and we do have to acknowledge our ledge history. If y'all saw on your walk this morning, this pond to the left of us right now, to the left of me, used to be the PG&E cooling pond for a coal-powered power plant that has now been replaced with an electrified one. The coal-powered plant was one of the dirtiest power plants in California, and it was the biggest source of air pollution here in Bayview Hunters Point, where residents are twice as likely to get asthma compared to the rest of the residents in the city. Residents and their only because of consistent advocacy and protest from residents for decades was the power plant able to be shut down in 2006 and then demolished in 2008. In 1998, before that, Literacy for Environmental Justice was born from the youth organizing movement in Bayview Hunters Point targeted towards this power plant. So this kind of ties into it because now we're sitting in the eco center, and what happened was because of Ledge's involvement with the power plant being demolished and the advocacy work, there was funding available through PG&E for the mitigation of the power plant, and a lot of that funding went towards the eco center, which Ledge had fundraised and wrote the grants for. So this eco center that we're sitting in right now, after the power plant was shut down, Ledge was able to see that there was a strong need for outdoor education space in this community, and that was our intention with working towards getting the eco center built. Built in 2010, Literacy for Environmental Justice, the Eco Center was the first LEED certified platinum building in San Francisco, operating 100% off the grid. This was built with the intention of creating an outdoor hub focusing on outdoor education for the community's youth of Southeast San Francisco. Now being operated by San Francisco's Park and Recreation Department, Ledge continues to use the Eco Center 25 years later as a physical tool to teach students and community members about wetland and sustainability through the lens of environmental justice. By telling the story of the historically polluted community and its struggle for a healthy neighborhood, Heron Park is an example of community-led advocacy for green space in real time. The eco center being built kind of like in conjunction of it was like the power plant was going down and the eco center was going up. So that's how we see it in real time, and that's how the history of Ledge kind of continues through the use of the eco center. I emphasize this on the back of our workforce development program, where we're able to position young people to advance into roles through city agencies, environmental nonprofits, consulting agencies, other orgs, other companies, while sourcing our workforce for habitat restoration hyperlocally to community members. Next slide. Just really quick, I'm not going to go into a lot of details of the whole process, but I will talk a little bit about our propagation of the Sueta californica, which is the endangered plant that Ledge has reintroduced with the help of Kathy Boyer's lab at the EO Center. We've been working on this since we began our contract in 2021, and it was 1 or 2 years of doing a lot of test plots, doing a lot of testing of the propagation in the nursery before they were able to come out and be planted. And even from there, we did a year of testing different locations within the park to see where they would do the best according to their location, their elevation, exposure to wind. I will say there were a lot of challenges. Some of the shoreline segments were unsuitable for planting, emphasizing the value of early mapping and early site monitoring. Also the timing of the planting. So originally, based on anyone who's ever done any restoration, planting seasons in the winter and the wet season We actually found benefit in planting in the summer with hand irrigation, outperforming a lot of the winter ones due to storm damage and gravel mitigation from the winter weather. Another thing that we found that was a challenge was it's better to plant these plants in larger containers because then we can use the sentiment from the plantings of a larger plant to help stabilize them as they get established into their new location. So it's interesting because we do now have one of the biggest populations of Sueda californica here at the park, and it's actually not on the berm, even though we do have a lot of successful plantings on the berm as of right now. But it's actually down, if y'all are familiar with the park, it's called Lighter Beach, and it's like right behind me. So if you walk right down to that cove behind me, and please do if you're here today, you will see a very beautiful, successful, established Sueda californica planting among other native plantings down at the beach, which has only been there for 3-4 years, and it's really beautiful. So I encourage everyone to check that out here today or another day if you come to the park. So a lot of wins that we can count from our work with the Sueda is that the cool thing about the berm and planting Sueda and also other native plants on the berm of the living shoreline was because the berm is permeable by seawater. We can plant things outside of our regular planting season, which, like I said earlier, is our wet season. So technically, we can plant through the summer, we can plant through the fall when we don't get rainfall, and they will get water based on tidal influence. So that's a benefit for us. And even this month into July, we're going to be planting about 200 more Sueda out on the berm. Another win is a consistent locally trained workforce that ensure long-term maintenance and project resilience. So because we were able to get this 5-year contract with the port, we are the people who not only grow the plants and put them in, but do the monitoring and the maintenance for them. So we all know that restoration doesn't just take 1 year. It can take minimum 5 years, upwards of 20 years. So it gives us funding as a small nonprofit to make sure that we are the ones who are ensuring the habitat is 1, monitored, and 2, maintained to have a successful established plants and habitat. If anyone has any questions about this Sueda, please let me know. I don't want to go into too much detail with it, but we'll go to the next slide. So over the last 5 years, with the goal of restoring tidal wetlands and transition zone habitats at Heron's Head Park, we've cultivated and outplanted over 30,000 native wetland plants and transition zone plants. We've introduced 200 to 400 individual Sueda californicas, a federally endangered species, and we continue to do invasive vegetation removal across the multiple acres of the wetlands and the living shoreline. Last slide, please.
And maybe one more.
Okay. All right, last slide. Ledge's role as a community-rooted environmental justice nonprofit has been critical to engaging residents and implementing on-the-ground work. We greatly benefit as a relatively small nonprofit from the multi-year funding, especially in regards to restoration work, including the monitoring and maintenance, as I just mentioned. The project combines ecological restoration, workforce development, and community programming, and demonstrates a model for inclusive, climate-resilient restoration through strong cross-sector collaboration. Thank you.
I'm gonna go real quick through this last section. I think there'll be time for questions. So if any of these topics you want more detail on, ask and we can go into it. I'll just briefly say we are currently in year 3 of a 10-year post-construction monitoring effort that includes monitoring the physical changes at the beach, how the gravel's moving, how the rock structures are performing, the wood, the oyster reefs, how those are moving relative to the sediment. Also ecological conditions. And so that includes monitoring oyster colonization on the reef balls, vegetation, and bird usage of the site. So we're doing quarterly bird surveys at the site. Next slide. It's a dynamic landscape. We've seen a lot of changes and kind of working with Nina's team who are out there very often, learning where the plants do the best has been really interesting. It's linked to wave exposure. The east side, that gravel moves a whole lot. The west side, much more sheltered, much more suitable for getting these plants established. Next slide. Couple topics I could go into more detail during questions if folks are interested. Beach morphology, we've been measuring the elevation changes of the gravel using drones. We're doing flights every other year. Briefly, the east side, the beach has gotten much taller, also narrower. The west side is more stable. It's gotten wider in the central section of the beach. Hasn't changed very much on the far west side of the beach. Next slide zooms in on the map. You can see it. Red here is accretion, blue is erosion. And so the beach has also migrated a few feet, 5 to 10 feet landward in the more wave exposed area. Next slide. Chayla Zabin and the Smithsonian Institute team has been monitoring the oysters. They're getting really good colonization on the reef balls. They're also seeing some oysters on the quarry rock that was used for the headland structures. And so that's something I'm interested in maybe them taking a closer look at during future years. Next slide. Also the sea blight monitoring, Nina alluded to this, and that's an ongoing thing, keeping track of how and where they're having success with the plantings and where is it being, where is it more difficult to inform future reintroduction efforts. Next slide. Also fun, I look at eBird way too much for this site. Very cool to see least terns out here the last month or so. I think someone spotted one yesterday, so that's great. It's an endangered subspecies. I think the whole least terns in general aren't endangered, but the California subspecies is. I don't know if they're breeding or anything out here, but they hang out, and that's kind of cool. So yeah. Yeah, and I think I'm going to wrap up. I've got a lot of reflections. I'm not going to read this. I've got thoughts about the gravel sizing, about that rock structure, and I'm happy to chat with anyone who's interested. Let's keep going though, in interest of time. Also, there's a lot of future topics of interest. I'll just say, I think this is a really cool project that's tested and demonstrated the benefits of this gravel beach nature-based approach to shoreline management. One thing I said this on at least one of the tour groups that I think is very cool is that because the peninsula has this gradient of depths, wave exposures, and also really active just monitoring and stewardship of the landscape, we're seeing site evolution of what's possible in a range of conditions. So I think there's a lot that we'll continue to learn from this site going forward, and hopefully I'll be sharing out some more findings in the future as we continue monitoring. And I think with that, I'll just thank everyone who's made this project possible. And in particular, I'd like to call out Carol Bach from the Port of San Francisco, who, yeah, I think she's now mostly retired, but she really did put so much of her heart and soul into this entire site, the eco center, going back to the original projects, through the whole beach stabilization. So just, yeah, a lot of credit to her. Thank you.